All right, so let's go ahead and establish the connection that we may have seen in the previous investigation. That said, that was dealing with a triangle, but an exterior angle of a triangle. So obviously here's a triangle, and as the word exterior implies, that just means on the outside. So really any triangle you have, you can always make an exterior angle by pretty much just making a side go longer. Right? That's not like anything special other than any triangle, if you extend one of its sides, can have an exterior angle as far as part of it or in the diagram, right? And I could, of course, extend this side down here if I wanted, or extend any side really, and you would have an exterior angle. So yeah, here we go. There is an exterior angle. I just extended that one particular side. Now the investigation, it was always being compared to, or it seemed to be that it was always equal to the interior angles that were far away from it, like angles 2 and 3. But there's terminology for all these things. And you may have already guessed that angle 1 is called the exterior angle. There's a name for what 2 and 3 are as well. The name of those angles are the remote interior angles, and that's always as it compares to or relates to an exterior angle. Like you would only use that terminology if we have an exterior angle being discussed or in the diagram. I think the word interior probably helps you remember they're inside. The way I see it, you use a remote when you're kind of far away from something. If I can just touch the buttons, I would. But when you're far away, you click the buttons of the remote to then activate the change in the TV or whatever it is you are controlling. So they're the interior angles, the angles that are inside that are as far away as possible from the exterior angle. Again, they're called the remote interior angles. And as you might recall in your little investigation, the measure of the one exterior angle is always equal to the sum of the two remote interior angles. That one angle on the outside always be equal to the sum of the two angles that are inside the triangle, but as far away as possible from the exterior one. Again, if I go back to the diagram, pretty much saying angles 2 plus 3 will always equal angle 1. Okay, so we look at this diagram. Hope you can acknowledge 5 is the exterior angle, and 2 and 9 are the interior angles. So this is incorrect, right? We'll be a little careful. We're definitely talking about 5, 2, and 9. 7's not going to do much for us. But in this situation, that's wrong, right? It should say measure of angle 5 equals measure of angle 2 plus 9. Okay? Just be careful with what you're connecting. 5 is the exterior angle, and 2 and 9 are the remote interior angles. And the sum of 2 and 9 will always be equal to angle 5. What about in this diagram? A lot more to consider, but see if you can take a second and think about some of the equations that would apply here as far as which exterior angle is equal to the sum of which two remote interior angles. I'm going to talk in about 10 seconds, but if you want to go ahead and pause it now before you hear the answer, feel free to do so. All right, if I'm talking about 1 as being the exterior angle, it's equal to the sum of angles 3 and 7, because those are the two remote interior angles as compared to angle 1. If I was talking about the exterior angle, angle number 9, that would be equal to the sum of angles 5 plus 7, because those are the remote interior angles as regards to angle 9. If I was talking about exterior angle 2, that would be equal to the sum of angles 3 and 5, because those are the remote interior angles as they relate to exterior angle number 2. All right, let's see what you can do.